This is June 2023. Paper 1 month, and we are starting from question number 21. The graph shows the variation with time of the displacement of a particle in a progressive wave. Two measurements x and y are labeled on the graph. What do x and y represent? Apparently, it looks simple question because x is the vertical side and y is the horizontal side.
So it will be A, right?
It should be because x is the amplitude and y is the period. Double check. X-axis is time period, y-axis is displacement. So it's quite visible that this is the time period and this is the amplitude. That was a easy starting question. A car travels at a constant speed. This is something which is always important to remember, that these type of concepts should be underlined, because when speed is constant, it means resultant force is zero. A loudspeaker attached to the car emits sound at constant frequency. A stationary observer is at point O. Now it looks like a Doppler effect question. What does the observer hear as the car moves from P towards Q? Where is observer? Observer is at point O. Acha. Observer is at point O. This is a Doppler effect question. What does the observer hear as the car moves from P towards Q? So car is going towards Q. So car is getting closer to position O, but actually the car is not approaching directly towards O, but it's going to pass ahead of that point.
Will it be D?
So we need to know that how we decide this question, because this is a theory question. So elimination should be used. A frequency less than f that decreases as the car moves from P to Q. Frequency less than. Now less than doesn't make sense to me, because when it is approaching, when it's getting closer, frequency should increase. Now you have to see this question number 11. Sorry, 22. A and B are out of question because frequency less, frequency more than f. What is f? Acha, frequency is the frequency of the source. Remember, the observer is at position O. The trick is here, as the question does not say that the observer is right in front of the point, right in front of the car. If the observer is standing at position Q, then C should be the answer. D should be the answer. The frequency more than F, frequency should increase. Now the question is that either it is A or B or C or D. So we select A or B, we reject it because frequency is less. Now how we decide between C and D? A frequency more than F that increases as the car moves from P to Q. The frequency more than F that decreases as the car moves from P towards Q. Now between C and D. I'm also trying to show the relevance of examiner report. The question needs some understanding of the theory, Doppler effect theory. Candidates found this question very challenging. The majority deduced correctly that the frequency heard by the stationary object would be greater, as we also observed, than the frequency of sound F emitted by the loudspeaker on the car as the car is traveling towards the observer. Now look at the way they have explained it. So they have drawn a wave diagram, a vector diagram. The component of the car velocity traveling directly toward the observer is V cos theta. As the car travels towards Q, the value of theta increases, so cos theta, and hence V cos theta decreases. The frequency heard by the observer will still be greater than F, but will decrease as the car travels from P to Q. Answer is C. So this is the reason I always advise students to use the examiner report. It's very helpful, and they have highlighted a very interesting concept here, the contribution of cos theta. Now, someone who's taking maths already know that as theta increases, cos theta actually decreases. But everyone should otherwise remember it. It was a concept in projectile motion that as theta increases, cos theta, V cos theta decreases. The component actually cos theta, when you increase from cos 30 to cos 60 to cos 90, it has to become 0. Cos 90 is 0, cos 0 is 1. So when you remember this rule, you can very easily judge that there are two components of velocity. So this is how we can solve this question. Now look at this position. So if we resolve the component of velocity, like this. So if we resolve it, we will find that there are two components of velocity and the angle is increasing. So if we draw this angle here, we draw the angle here, we draw the angle here. If we say it is theta, so theta increases. Now, how a student who was not taking math should remember it? Remember cos theta. If I take cos 0, cos 0 is 1, cos 30 is 0.866, cos 60 is 0.5, and cos 90 is 0. So as theta as theta increases, V cos theta decreases. This is what the examiner report told us, and V cos theta decreases. V cos theta decreases. That is why we have to select the option C, because the velocity will decrease. So this is a guidance that examiner reports are very helpful. Some sources of electromagnetic waves in free space are listed: a radio wave, a source of X-rays, a 30 millimeter wavelength radar transmitter, a light emitting diode that emits red light. A light emitting diode that emits red light, which list gives the sources in order of increasing wavelength from left to right of the waves emitted by the sources. Now, this is the case of remembering that the electromagnetic spectrum. So always we have first gamma rays, then X-rays, then UV, then Vidgire, and then micro, and then radio. These are the waves.
Sir,
If
what would radar transmitter come under?
radar waves are man-made waves, na? So he's just like trying to confuse, but he has given the wavelength 30 millimeter. Radar waves are either microwaves or radio waves. We know that because radar waves are man-made, and you know micro and radio are man-made. So definitely radio or micro, any one of them, or you, if you remember the values, 30 millimeter is the value table, 30 millimeter wavelength. So from left to right, lambda increases. So radio transmitter is given, radar transmitter is given. Now X-ray, X-ray should be the least wavelength. X-ray should be the least wavelength. So one is there. It's in the order of increasing wavelength. So X-ray should be the least. After X-ray, should I select red light?
Yes.
So it means 2 is confirmed, 4 is confirmed.
Let's see.
So, but what about now the tie is between radio wave? Do you remember the wavelength?
Yeah,
The table of wavelengths? Which we have learned many times, but that wavelength table is very important.
Is it 10 to the power minus 1?
You can remember that, and let me post it again so you can remember it and you have to learn it. Now I have posted it again. So can you use this table? Because now we have to decide between 2 and 3. No, sorry, 1 and 3. We need to find 1 and 3.
So it will be C because radio wave has the biggest wavelength.
How much is a radio wave in that table? If I do not remember
0.1 is 0.1.
In this table, it is wavelength is 10 power minus 8 to 4 power 10 power minus 13. Radio is 0.1. Acha, radio is greater than 0.1. But he says meter. And he says 30 millimeter. Acha. So radio wave is 0.1 meter. And this radar is 30 upon 1000. How much it would be? 30 upon 1000 will be, how much 30 upon 1000 is? 0.03.
Yeah, so it's still smaller.
Now it's a good comparison. So it means that 1 and 3 is smaller, right? See. A vertically polarized beam of light is incident normally on a polarizing filter. The transmission axis of the filter is at an angle of 40 degree to the horizontal. Transmission axis of polarizing filter, beam of vertically polarized light. And this is the horizontal axis. Beam of transmitted light. What is the ratio of amplitude of transmitted beam upon amplitude of incident beam? What is Mole's law? Can we recall it? X is equal to x naught cos theta.
Yeah, I is equal to I not cos
I
theta.
is equal to I naught.
Cos theta square.
Good. I is equal to I naught cos square theta. I naught is the incident one, right? So I should make it like this, I upon I naught. Now this is the equation. Now, can you help me out how we proceed forward now? We are at this position, I upon I naught is equal to cos square theta.
Since they're asking for amplitude, we'll do I is directly proportional to A squared.
No, actually, you are right, because I was thinking that we first find this cos I upon I naught, and first we find this ratio, then I1 upon I2 is equal to A1 upon A2 whole square. Then we remove it and we take I1 upon I2. So that we are clear about that. That's perfectly right. But what about this cos squared theta? How we solve that? Yeah. This is the next step. Calculator should be in degree mode.
So cos 40 square, which will be 0.59.
And then we square it, right? You have squared it, 0.59.
No, it's just cos 40 square.
But you have squared it after cos 40 square is how much?
0.58.
0.58. And if we underroot it?
0.76. 0.77.
We have to check the working, 0.77. Where come? Achha, 40 is coming from here. Okay. Let's see what he says. Double check. But he's taking 15. How is getting 50 and what is the issue? Achha, we are taking the angle wrong actually, because the total angle is 90. This is our mistake. Actually, the angle is given with the vertical axis. Angle is taken with the line of transmission. Line of transmission angle is 50. So our working is right, but we were taking a wrong angle.
So that will be 0.41. And if we square it, it will be 0.64.
0.64.
Yeah. Over here, why don't we add 40 with 50? Why
Add
do
with.
we minus it? Why do we minus 19 minus
So
40?
because it was a small thing to remember that the 40 is given with the vertical axis. The beam is traveling on the line of transmitted light, the arrow line. Angle should be taken. Angle should be taken. Angle should be taken with the positive line of transmission. So we have to subtract it from 90 because the angle was not given with the line. So it's a basic math rule. If the total is 90 and one angle is given, so the other angle would be 90 minus 40. Two progressive waves meet at a point. What condition must be met for superposition of the waves to occur?
They must be of the same type.
Two progressive waves meet at a point. What condition must be met for superposition of the waves to occur? The waves must be coherent. A coherence is a condition for interference, but he's not talking about interference. He's talking about superposition. Same type is right. Must be traveling in opposite direction is not necessary. The waves must meet in phase. That is also not necessary. In phase is one option. A string is stretched between a vibration generator and a fixed point. When the vibration generator is vibrating at a frequency f, a stationary wave with 5 nodes is created on the stretched string as shown. There is a node at each end of the string that is attached to the vibrating generator, and there are 5 nodes. So let's make the 5 nodes. Node here, node here. Look at this. The frequency of vibration of this is slowly increased. What is the next frequency that produces a stationary wave on the string? So there is a node at the end of the string that is attached to the vibration generator. So he says frequency of vibration is in generator is in slowly increased. So this is the 4th overtone, and he wants to get the next overtone, next frequency that produces a stationary wave on the string. If there are presently 5 nodes, do you think the next will be 6 nodes when you get the stationary wave again?
Yes.
So if we follow this approach, let's try to make the separation won't change. The separation obviously between the source and the thing will not change. So let's see, the separation is L. The speed of sound also does not change. So can you tell me how many wavelengths are there? Node to node is always node
Is lambda by 2.
is always lambda by 2. So it means if I take this separation here,
It's 5 by 2 lambda.
Lambda by 2 should be lambda by 2 into 4.
Isn't it 5 over 2?
No, but there are nodes. Nodes are 5, but the separation is 4 now. If you count the separations, node to node, node to node, node to node, how many separations are there?
Yeah, they're 4, sorry.
So it means it will be lambda by 2 into 4, which means 2 lambda. So it means L is equal to 2 lambda. Now, how we proceed? We have made our, we need to get the next one. Length is the same. So we can say lambda is equal to, let's say it's lambda 1 is equal to L upon 2. What's the formula? V is equal to F lambda. F is equal to V upon lambda and V upon L upon 2. So if I take it F1, it will be 2V upon lambda. The present frequency is F. So I'm removing the 1. It's not F1, it's F. He's using this letter F. Okay. Now we got this one. Now this is our first equation. How I can make the next equation? He says next frequency. So when you get the next frequency for which a stationary wave is produced, it means we can try with 6 nodes. How much it will be for the next node? If there are 6 nodes, it will be lambda by 2 into 5. And lambda will be equal to 2L upon 5. So now try the same thing. F is equal to V upon lambda. F is equal to V upon 2L upon 5, which means 5V upon 2L. This is my next frequency. Yes, please go ahead.
Yeah, we're saying the same thing.
Okay, now can you combine them if I want to get the final value, because I have both the values now. No? I want to make a ratio. F prime upon F, making the ratio. F prime upon F. So 5V upon 2L upon 2V upon L. So now do the cancellation and help me solve the equation remaining. LL cancel, V and V
That will
cancel.
be 1.25.
1.25.
Yeah.
1.25. 5/4.
No, it's 5 divided by, yeah.
So we got the answer. This is the answer 1.25. So you can see that this was a bit challenging question. And you should remember that people always look for other solutions and other, but even new examiner reports are very helpful. A ripple tank and a barrier with a single gap are used to demonstrate the diffraction of surface ripples on water. Initially, the wavelength of the ripples is 5 times smaller than the gap in the barrier. The wavelength of the ripple is 5 times smaller than the gap in the barrier. So it means the gap is bigger than the wavelength. Which change increases the amount of diffraction. Achha, increase in diffraction means what? When the waves go from here, definitely they are going to like this. They will bend like this. Examiner wants to increase the degree of diffraction. It means that more, he wants to have more bending. He wants to have more bending. So ideally, I should decrease the gap size, the slit width. So double the width of the gap will actually decrease the diffraction. Double the amplitude of the ripple. Now this is wrong because amplitude is nothing to do with diffraction. So two options are bounced. Half the frequency of the ripple, and as wavelength is not changing, so half the wavelength of the ripples. Now these are the two things.
Will it be C?
Now answer looks fine to me, but why? Half the frequency of the ripple, velocity is constant. If I keep velocity constant, look, V is constant, and it means frequency and wavelength are inversely proportional. So when you double the frequency, when frequency is 2f, it means, sorry, frequency is halving, sorry. Frequency is half. It means wavelength will be double. Frequency is half, so wavelength will be double. So if I double the wavelength, what will happen? Presently, it is 5 times smaller than the gap. So this ratio will drop 5 times smaller. So wavelength will increase. So when I increase the wavelength, what will happen? Logically, remember this concept. For good diffraction, wavelength should be greater than the gap. The gap should be very narrow. Gap should be smaller. The slit width should be smaller than the slit width should be smaller than the wavelength. Here it is opposite. Here the slit width is bigger than the wavelength. So for more diffraction, slit should be narrow and it should be smaller than the wavelength. So if we increase the wavelength, waves will bend more. This is the concept. A laser produces a beam of light of wavelength 650 nanometer. The beam is incident normally on two slits that are a distance of 0.12 millimeter apart. So this will be the value of A. The bright if interference fringes on the screen have a separation of 7.5. This should be X. Screen and the two slits. So this should be D. The formula says X is equal to lambda D upon A. Now I have the formula, I have the values, but what should I would do with lambda? Wavelength is 650 nanometer. So I think we should convert it. Lambda is 650. I should rearrange it first because I should get it be the subject. And lambda is 650. So solve this.
We'll get 13.8, so it will be 14.
13.8. A beam of light from a laser is incident normally on a diffraction grating. The diagram shows only the second order maxima that is produced. The grating has a line spacing of this. The angle between the two second order maxima is 110. What is the wavelength of the light? Angle, as we were discussing in another question, angle should be taken with the horizontal line. I draw a horizontal line. And what would be the angle now? If I draw this angle, it will be 110 upon 2, like this. So I have the angle and I have the formula. What's the formula? N lambda is equal to,
So we're always supposed to have it?
sorry,
We're always supposed to have the angle?
it's a basic math rule. It's a line of symmetry. So if both are n is equal to 2, this line is n is equal to 2, and this line is also n is equal to 2, the two orders. The angle between, look, this line, the angle between the two second order maxima. So in that case, you always have to have if both orders are the same. What is the wavelength of the
That I
light?
remember.
So see this working. You can also then post your answer if you want on the chat.
It will be 4.1 times 10 to the power minus 7.
The electric current in a metal wire is 4 milliampere. How many electrons pass a fixed point in the wire in a time of 10 hours? So for that case, what's the formula? These are the formulas. So if you equate them, what is the value of E?
1.6 times 10 to the power minus 19.
Minus 19. Oh, that's right, minus 3. Thirty. Now try to solve this.
And 9 times 10 to the power 20.
10 power.
20.
What is the definition of the potential difference across an electrical component? So it's a memory. Potential difference is V, and V is equal to W upon Q. It's a charge per unit time passing through the conductor, energy transfer per unit charge, force per unit charge, and resistance per unit current. So 31. By definition, what should we take? It's a memory. It's work done per unit charge.
Would be
Hmm. Which graph shows the IV characteristics of a filament lamp? Now, this is again a memory. Filament lamp resistance increases, graph bends, towards V axis, voltage axis. Graph bends towards voltage axis. So 32. It's a memory actually.
so it will be D.
A metal wire has a length of 2.5 meter, cross-sectional area this, length this. The resistivity is given to be this much. The wire is stretched so that its length increases to 2.65. So this is L1, this is L2. The wire remains cylindrical and the volume of the wire remains constant. What is the change in the resistance of the wire? Resistivity is a constant. But what about this area? He says volume remains constant. Length has increased. The wire remains cylindrical and the volume of the wire remains constant. So what should I talk about area? Because when you are stretching the wire is stretching and you want to keep the volume constant. So do you think area will change or area will decrease to compensate? Otherwise, increase in length will decrease. Increase in length will change the area, will change the volume. He wants volume to be constant.
Area will still change, right?
Area should change inversely. Resistivity is a constant. No doubt resistivity is a constant because the temperature is not changing. Now, how I can get resistance in this game? I have a concept that resistance, but I do not know the area. The point is that how I will get the area. The first point is that. And he says he's giving me a word cylindrical. Resistance is proportional to length. Resistance is proportional to 1 upon area. But without a new area, he says, what is the change in the resistance of the wire? He's talking about delta R. volume is cylinder volume. I give the formula for volume of cylinder also, pi r square into h. Or in easy terms, volume is equal to area into length. So I have this formula, volume is equal to area into length. Length increases to 2.65. Volume is constant. I can get the new resistance. I can get the new length, sorry. I can get the new length and then we can apply the ratio, but how we can get it? So let's start our work. If we know the formula, volume is equal to area into length. V is equal to area into length. So area is inversely proportional to, he says volume is constant. So area is inversely proportional to length. So we can find it and we can first find, we should try to find the new length. A1 upon A2 is equal to L2 upon L1. So I have the area 1, I have the length 1, I have the length 2. So please help me to find the area 2, A2. And here I can make a relation. R is proportional to L upon A, and I can say that R1 upon R2 is equal to L1 upon L2 into A2 upon A1.
A2 will be 4.2 times 10 to the power minus 6.
This is right. You can do that. Or you can also say that A2 upon, A2 upon A1. So you can also keep it there. Because volume is constant. Na? So you can also, but anyways, you got the value of L2, right? Sorry, A2.
Yeah.
So what A2 you got here?
4.2 times 10 to the power minus 6.
Then you put all the values in the above equation. And we can find R1 upon R2 in a ratio. Resistance is equal to rho L upon A. I have all the values. Meanwhile, also find the resistance for me.
Will be 0.88.
Sorry,
0.88.
what is ratio? This R1 upon R2?
Yeah.
Okay, now find R1 also. We have the resistivity, we have the length, we have the area. Put them all to find R1. Then your answer, if you want to contribute in any answer, please you can write on the chat R1. We are presently calculating R1.
It is 0.19.
0.19.
19.
Acha, R1 upon R2 is 0.88. Now we are on the final position. You can find R2 from this equation.
Or 0.22.
0.22.
Will it be 0.19 divided by 0.88?
0.19, 0.19 divided by 0.88.
Yes, and then it's 0.22.
Okay. Then can you check the answer and we can proceed? Which circuit symbol represents a microphone?
Wait, the answer is B though. It's 0.024.
Then which circuit symbols represents a microphone? Now it's a memory.
See?
A battery with internal resistance is connected to a fixed resistor, an ammeter, and a voltmeter. This looks to be a theory question. The battery is replaced by a different battery that has the same EMF but a greater internal resistance. What happens to the readings on the ammeter and voltmeter? We have some internal resistance in a voltmeter. A battery has some internal resistance. This is the internal resistance. This is the external resistance. The battery is replaced by a different battery that has the same EMF, but a greater. So battery voltage is the same, but the internal resistance is increased. We have a formula for EMF. I E is equal to I R plus R. If I make, current, ammeter means current and voltmeter means V. So if I take I the subject, I is equal to E upon R plus R. Examiner says that EMF is constant. So now small r is in the denominator and he says he's going to increase the R. Internal resistance is going to increase. So by mathematics fraction, the current should increase or decrease?
Decrease.
Current should decrease. Very good. So C and D are rejected. Option now, game is now between A and B. What is V? Actually, this V, this voltmeter is giving us external PD, terminal PD. When internal resistance increases, do you think the greater voltage will be lost inside the battery?
Yeah, so voltmeter reading will also decrease.
Because the internal resistance will take more share. So V across R increased. So V across capital R decrease, because total has the same, the two voltages, terminal PD and terminal PD and internal PD, sum to the EMF. So it is a logic that if the battery is 10 volt and internal resistance will take more voltage, less voltage is available outside. Four potential divider circuits each consist of a battery of EMF 9 volt and negligible internal resistance connected to a combination of resistors. Each of the resistors in the circuit has a resistance of X or 2X. Okay, X, X2X, XX. Which circuit has the largest output voltage? Is it a potential divider? It is a potential divider, and the formula, if you make a potential divider, the voltage is divided in series in the proportion of resistance, because it's a series circuit. Voltage is proportional to R. So if I start my working, it's 9 volts. It is, if it is 9 volt, it will be 4.5, and it will be 4.5, and it will be 4.5. Achha, here it is X and 2X. So in this case, the ratio is 1:3. So I will take 2/3 into 9. I'm using the formula. So I will get 6 volt. Now here, he has made a game here. He has attached two resistors in parallel. So can you tell me what is the effective resistance of this? They're in parallel. X into 2X upon X plus 2X. It will be 2X squared upon 3X. It will be 2/3X. Now apply the ratio. X ratio 2/3X. I need to find across this circle. My V is across this circle. So what I will do, it is 1. So I will do 2/3 upon 1 plus 2/3 into 9. So try to solve this.
It will be 4.
4. Oh, I'm not getting 4.
Sorry, 3.6.
3.6. Okay. So I get here 3.6 volt. Now here they are in parallel. So 3/5 will be now the above one, 2/3 will go up. and this is 1. So the ratio is 1x into 2 upon 3x. But this time it's across 1. So 1 upon 1 plus 2 upon 3 into 9. So 1 upon 5 upon 3 into 9. Try to solve this.
5.4.
5.4 volt. Which has the largest output voltage?
B.
Yes. Oh, right. A voltmeter is connected into a circuit with the polarity shown. This is plus, this is minus. It's also looking like a potential difference, and the cells are in opposite polarity. The sliding contact is moved to NP, is moving this towards down. And then to NQ. First it goes down and then it goes up. What are the two readings of the voltmeter? Sliding contact at NP. When you reach position P, resistor roll is finished because you're not taking anything from the resistor. So when you reach, when the slider, look at the slider, when slider reach here, you're not taking any part of the resistance. So at this position, the 3 minus 3, because that's the only resistance. When you take the full amount of it, so it will be, first you look from this position. Now you're not taking any voltage from the source cell. Let me call it the source cell. So if I go on the lowest position, I'm not taking any voltage from the source. So this cell in this position is not getting any voltage from the source cell. So at this position, it will be 3 minus 0, it will be 3 volt, because nothing is coming from the other cell. Achha, what about in position? What about the position when the slider is on the topmost position? Look at the slider. Let it here. This is the topmost position. At this position, full voltage comes from the source cell. In that case, we have to see the polarity, plus minus. When cells are connected in plus minus polarity, should we add up the EMF or should we subtract the EMF?
You will add?
Yes, plus minus polarity. So it will be 3 plus 3, 6 more. A proton has mass MP and charge plus E. What are the mass and charge of an antiproton? Antiproton means that the mass will be negative or mass will still remain positive.
Mass will remain positive, just the charge will become negative.
Yes, so it means that these two options are wrong. Charge of a proton is plus E.
So it will be minus E.
Anti what means?
Opposite.
A uranium nucleus has 92 proton and 143 neutron. The nucleus emits a total of 3 alpha and 4 beta particles to form nucleus X. How can nucleus X be represented? A total of 3 alpha. Now, alpha means, first we talk about alpha. So, alpha means, if we go for alpha, A minus 4 and Z minus 2. This will happen 3 times. Beta minus, beta means X, no change, mass number, no change, and atomic number increases by 1. So 3 alpha and 4 beta. This is the atomic number and this is the mass number. So I can say 3 alpha plus 4 beta minus. So I can say 3. If I first solve for mass number, A minus 4 plus beta does not change the mass number, but atomic number changes by 12 because 4, 4, 4. So let's talk about the mass number first. 3 alpha and 4 beta. Mass number does not change by beta. So I have this. So it is 143. So should I subtract 143 minus 12 plus 0? Because beta has no change for, beta does not change mass number. So how much is 143 minus 12?
131.
131. By rule, we should get the answer, but we should double check 92 protons. Now, talk about atomic number. So should I subtract 6? 92. 92 minus 6. What about beta? Should I add 4 in it? Because 1 beta is 1. So 4 times beta is plus 4.
So it will give us 90.
Yes.
Oh, wait, sir, the answer for the previous one is D.
So 235 minus 12 plus 0.
It will be 223.
That was a big mistake. 220. 220.
223.
Which statement about a proton is correct? A proton is a baryon, but not a meson. A proton is a meson, but not a hadron. Proton is a hadron. So proton is not a hadron is wrong. Proton is both a hadron and a meson. Proton is a meson and a baryon. So proton is a hadron. That's sure, because hadron are those particles which are inside the nucleus. Proton is a hadron, but it's proton is a hadron. If we think about proton is a hadron, and within hadron, proton is a stable baryon. This is the link. So proton is a baryon, but it is not a meson, because meson is a second type of hadron. Sure. Can you send me the PDF? You were asking for a question, some questions. So can you send me the PDF?
I'll send it.
Okay, just a minute. Huh? I'm just coming. Send me the PDF.